First of all, well, thank you, Elena, for the introduction and to have introduced this dual plenary session in the program. And in my in my talk, I will share with you the results of some studies that we have performed at the ETH during the last years on the economics of, or on the energy efficiency gap, using insight from behavioral economics. And now, why behavioral economics? Well, I'm telling you that 10 years ago was more really a neoclassical, typical neoclassical economist. I didn't know what, well, behavioral anomalies were and so on. And then we have performed a project for the Swiss government at that time on modeling the choice of the renovation modes of single-family houses or owners of single-family houses. And one question that we introduced in the survey was about, did you perform an investment analysis before taking the decision of the renovation modes? Did you compare the different renovation modes, also from an economic and financial point of view? And 30% or 40% of the people say yes, but the other 60 say no. And then I say, okay, look, if we continue to try to contribute to the solution of the so-called energy efficiency gap without opening a little bit the vision and the framework and the tools, the theoretical framework, then the risk is that we will not find any policy measures that will have an impact. And for this reason, we start with the help of some people and colleagues that are here in the room. We start a research program in this direction, using insight from behavioral economics for trying to identify some policy measures that could be effective in solving the so-called energy efficiency gap. Now, I organized the presentation the following way. First, I will spend some time talking about energy efficiency gap and the relation to boundary rationality. Then I will present some results of a European study that we have done in the last 3 years, the PENNY project, on the level of what we call energy-related financial literacy. And I will explain later on which is the definition. And then in the second part of my talk, I will present some measures that can help consumer to take sound decisions when we are talking about or energy-related investment decisions. Now, of course, well, this is a diagram that most of you know. To fight climate change, we need to reduce CO2 emissions. And here is a figure from the International Energy Agency, and they show how we could reduce the CO2 emissions with several strategies and so on, promoting renewables. But what you can see is that energy efficiency is very, very important. And, and if you think about also the role of the residential sector in the energy demand, then you can conclude that improving the level of efficiency in the use of energy in the residential sector is also crucial. Now, why we are wasting or how we are wasting energy? And basically, in the residential sector, we can think on two ways how we waste energy. On one side, sometimes we use in an inefficient way the electrical appliances, heating system, cooling systems, and so on. On the other side, we observe a low adoption of new energy efficient technologies. And this is, I will come back 1 minute, related to the concept of energy efficiency gap. Now, for me, it's very important to underline the fact that the energy consumption is strongly influenced by one decision every 10, 15, or 20 years, the investment decisions. When we are buying a car, when we are buying a fridge, this decision will influence the electricity consumption for the fridge for the next 10, 15 years. And this means that if we are able to modify or influence this decision, then we will have an impact for the next 10, 15 days. Years. If you think about, you can receive a message, SMS message, and say, well, switch off the light, or and so on. There are this type of intervention, but these are more oriented to the reduction of consumption. And I don't know if in the middle term, long term, still have an impact. Now, this is the typical definition of the energy efficiency gap. Individual decision makers do not choose the most energy efficient technology, even if this technology is also the most cost efficient choice. This means that minimize the lifetime cost. This means that you have the usual formula that compute the lifetime cost between, for instance, 2 appliances or 2 heating systems. And then you see that sometimes, even if the more energy efficient technology shows lower lifetime cost, then the consumer, they choose the alternative, less efficient technology. Now, in the literature, of course, you can find several factors that try to explain the barriers for the adoption of energy efficient technology. And the classical, you have on one side the classical arguments based on market failures. But on the other side, the last 10 years and so on, you can find a growing literature that make use of insight from behavioral economics and try to explain, using consumer anomalies, try to explain the energy efficiency gap. Here you can see the typical barriers like external negative externalities. This means that the price are not considering all costs or imperfect information, credit and liquidity constraints. Then you have principal-agent problems, landlord-tenant, and also positive externality in the adoption of new technology. On the other side, you have, and they will be more clear in the next slides, you have what we call behavioral anomalies. This means that we can represent these behavioral anomalies as systematic deviation from the assumption of the rational self-interested model of man, the so-called Homo economicus. And here you can represent in different ways these behavioral anomalies. Here I choose the approach that you have bounded rationality, bounded willpower, and then not really relevant for the energy efficiency gap, the bounded selfish. And now the focus of my talk will concentrate on the bounded rationality and the relation of bounded rationality with respect to investment decisions. If you think about the renovation of a house, of a heating system, buying also a simple washing machine, these investments show benefits and costs for a long time, over a long period of time, could be 10, 15 years for electrical appliances. If you are thinking about the renovation of a house, this decision will influence the energy consumption for the next 30, 40 years. And of course, from the economics point of view, it's very simple. We write down some mathematical model. There is an intertemporal optimization. I mean, the rational consumer should do this, should consider, if you think about 10, 15 years, should collect information, make some assumption regarding the price, electricity price in the future or oil price in the future, the utilization rate, I will have a family, not children, not, and so on. All these factors should be included in the decision process, perform an investment analysis, and from a rational point of view, choose the appliance or the heating system that minimize the lifetime cost, depending also on the discount rate and so on. Now, what we observe, and also during these studies, we observe in the real world that we have, the consumer is very simple. The consumer are heterogeneous. We have the rational consumer, that really they open an Excel file, they do all the calculation and so on. with scenario A, 1, 2, 3, and so on. But then you have also the boundary rational consumers, and then you have boundary rational consumers that are just boundary rational for some decision, but they become rational for others, and so on. So we have heterogeneous consumers. And the, for instance, if we consider a simple decision, buying a fridge, you have two fridges in front of you, they are similar characteristics and so on, but there is an important difference. Upfront price and energy efficiency or energy consumption. The rational consumer will do the calculation as we teach usually in typical microeconomics class, and then take a decision. The boundary rational consumer, and this is a concept introduced by Simon in 1982, make decision using limited information, cognitive constraints. Maybe he doesn't know how to do it. He's not really good in math, discounting what is, and so on. And then he take another direction. He take another decision process. He take the decision using some heuristic, choosing, for instance, by comparing purchase prices, just by comparing the energy label, or just by comparing the energy consumptions. The idea is that they should be at least satisfied. They are satisfier. They are not utility maximizer, usually. And of course, the decision to go in this direction or this direction depend on several factors. We have some traditional factors, I would say education, and there are in the room people that have done study on the role of education in the decision process for energy-related investment. Then gender, income, age, and then you have these behavioral anomalies, and within the behavioral anomalies, like loss aversion, limited attention, or present bias that you can observe for some consumers, we find here the term energy-related financial literacy, and I will explain now, presenting the results of this European project, this concept of what we call energy-related financial literacy. We are considering we consider three countries in our empirical analysis. And now, the concept of energy-related financial literacy is not completely new. In finance, the first time that the term literacy in economics has been used in finance. It's the so-called term financial literacy, has been introduced by Lusardi and Mitchell in 2008, for instance, or even earlier. And they say, knowledge of basic financial concepts, such as the working of interest compounding, the difference between nominal and real values, and the basic of risk diversification. This is the concept of financial literacy that has been introduced and related to investment decision on the stock market, or saving decision, or pension decisions. This was the idea of Lusardi and Mitchell. And what we have done, we started from this point, from this definition that is more finance-oriented, and we related this definition to investment in the energy sector, and we defined the energy-related financial literacy as the combination of energy-related knowledge and cognitive abilities that are needed in order to take decisions with respect to the investment for production of energy services and their consumption. And then we started to measure. How can we measure this, the level of the financial literacy and the level of the energy-related financial literacy? Well, we have done a large survey in Europe, and then we use three standard questions that are used in the finance literature about interest rate, compound interest, and stock option. And then we add some questions related to the lifetime cost. We ask people, please, calculate the lifetime cost. And then we observe if the calculation was correct or not. We ask, do you know the energy price, the electricity price? And I don't want to ask you now, but I mean, sometimes it's a difficult question. We don't know. But this is a very important ingredient in a decision process. Usage of cost of appliance. How much a washing machine is consuming, or other appliances. And here is, for instance, an example of one question. Financial literacy 2, imagine that the interest rate on your saving account was 1% per year, and inflation was 2% per year. After 1 year, how much would you be able to buy with the money in the account? These are the type of questions that we included. These are standardized questions. Then we had one on the lifetime cost calculation, where we asked the people to compute this lifetime cost. Here are the results. We have 4,600 households that participate to this service, or a relatively large sample for 3 European countries. And what you can observe is that the level of financial literacy in these 3 countries seems to be relatively high. You see the percentage of the correct answer is relatively high. But here you see that the other questions, well, the answer rate, the correct answer rate is relatively low. The knowledge of the price is very low. Also, the lifetime calculation is just 45%, 49. Now, so generally what we can conclude is that the level of what we call energy-related financial literacy is not so high. And this, of course, can be a problem, because if people, they have to take some investment decision. Here you have some difference across the 3 countries. As you can see, the knowledge of the electricity price is not so high in Italy. It's much higher in Netherlands and then in Switzerland. Also, for the lifetime cost calculation, we have some difference across the country. But one interesting difference is related to the gender. In the financial literacy, if you look at the paper by Lusardi and Mitchell, they found also a gender gap. And here we found the same. But here is related to energy investment decisions. There is a clear gender issue in the 3 countries. Now, we also started to do this kind of analysis in developing countries, and this is just to give you a flavor of what we are doing. In Nepal, we just measured the level of financial literacy, energy-related financial literacy, and the financial literacy. And also here, as expected, this is not a very new thing. As expected, we have a huge gap. But this is very important. Why? Because these people, we are talking about billions of people, they will take investment decisions in the next 10, 20 years. And we should be aware that or make sure that this decision will try to minimize the energy efficiency gap. We also try to identify the most important factors that influence the level of energy-related financial literacy. We estimate order profit model, and just to give you a flavor of the results, being female decreased the probability to have an outcome of 8. This means high level of literacy by around 5%. Being Italian decreased the probability to reach a high level of energy-related financial literacy by 6%, and so on and so on. Now, this is what we have is a picture of the European situation. Now, how can we help? Then the next question is, how can we help the consumer to take a decision? Of course, the literature, there is a growing literature. There are not many studies, but there is a growing literature in this field. Here, if you think about the prior, insight from the insight from prior research, well, there are some studies on the effectiveness of energy labeling and information. Einzel, Newell, and Sukamaki and Wood, they show mixed results on the impact of labeling, of providing a label on energy efficiency. By the way, in Nepal, you go around Kathmandu and you find washing machine but no label. And then you ask, yes, but did you communicate the energy consumption, electricity consumption? No way. And it's not so cheap also, the electricity. Alcott and Tubuinski and Alcott and Zwini and our work showed that there is a positive impact, for instance, of disclosing lifetime cost, no effect of more information through sale agent on energy efficiency, positive impact of providing monetary information on energy efficiency. These are results from prior studies. Then we have insight from prior research related to the impact of energy literacy and financial literacy. Here we have Brown that show that financial literacy is unrelated to conservation behavior. We had Goodline and Joachim Schley that is sitting here that show that the labeling schemes are more effective for customers with a higher level of energy literacy. And then Brenton Ward, this is the first, one of the first studies that tried to analyze the impact of the financial literacy on the willingness to pay for reducing operating costs of energy of durables, but using a stated preference approach. And now what we have done. Here I will show the results that we obtained in several studies that we have performed recently. We try to analyze the impact of 4 treatments. First one on information treatment. You see, this is the label used in the US. And in the US, you see that there are some number, monetary number. Here, we are back in Europe, no monetary number. Now, the question is, well, should we copy, at least in this dimension, not in other sectors and so on, should we copy what they are doing in the US? This was, we wanted to test this. Then we wanted to test the impact of providing some very short course on how to compute lifetime cost with some slides. Then we tried to test the effect of providing consumer with an investment calculator. And then this is relatively new. This is we organized our RCT in order to analyze the impact of the audit at home, providing not just technical information, but monetary information. This is the novelty. Monetary information for single appliances, washing machine, fridge, and so on what they consume, these appliances, what they could have and find on the market today. And this comparison this is a nudge, the idea was, well, should induce people to substitute the washing machine or the fridge with a new one that is more energy efficient. These are all these studies has been based on a randomized control trial or experiment. And we have control and treated group. These are the treatment that we use. I will go a little bit faster. We tested with, we have always relatively large sample for each of these treatment. We are more than 1,000 households. And we found that information on operating costs has an important positive effect on the choice, as the educational program has a positive effect, but not so large, because maybe people, they don't like to learn, or they don't spend a lot of time learning how to do a calculation. And then investment calculator has an important positive effect. And then here is the treatment that we use in the recent study. We have organized in-home visits. Students went there, they check the appliances, and then they come back with the information, and then we send a letter stating, well, you have this washing machine, today is consuming this amount of kilowatt hours, costing this, you can find on the market a good alternative. The results? Well, when treated household purchase new appliances, they choose new appliances that consume on average 15% less than those chosen by the control group. This means that this instrument seems to work. Now, conclusions, what we can learn? Well, from a energy policy point of view, I think it's not that we are solving all the problems and so on, but we can contribute with some instrument to reducing this energy efficiency gap. We could oblige producer of electrical appliances to communicate and provide monetary information on the yearly consumption, typical yearly consumption of appliances, promote educational training, decision support tools, promote home energy audit. All these measures, they would empower the consumer, but of course, we should think about also from a technological point of view. In the near future, the set of digital and information technology, home automation, new algorithms of artificial intelligence and also machine learning will play an important role in helping the consumer. You can imagine tomorrow, in 5 years, that the washing machine, when you are using the washing machine tells you, well, I am old, maybe you need to change me, and on the market you will find already another similar washing machine, because this you could organize easily already today, because all information are available. Thank you for your attention.
It's a pleasure to be here and to give this dual plenary talk today. It's a topic that you might find quite exotic. I do so too, and it's quite an exploratory work I did in the frame of a book chapter. It's an Elsevier book that will be forthcoming this September. And I asked myself, what do economists contribute to energy poverty, energy justice, and prosumers or prosumage? We did some research lately on prosumer households. I only have 1 or 2 slides on that, but I would try to give you a brief tour of what I discovered when I looked through the literature. So there is a rapid rise in the interest in politics, in society, in science, in research. There are terms to be clarified, terms that have been misinterpreted or interpreted in different ways, pretty much like we find in the rebound literature, by the way. There are many dimensions. There is heterogeneity that is at stake or at the discussion. And you're all aware of the energy trilemma, these triangles. And think about yourself which corners you have in your triangle. And then you can measure poverty and injustice by metrics like Lorentz curves and Gini coefficients. Most of you will be familiar with those concepts. And finally, there is this sustainable energy transition we're talking about now at this conference from many different perspectives. Now you see some pictures, think about them. The Yellow West movement, the Greta Thunberg movement. Now, she recently visited the Hambach forest, that's near Aachen, where lignite is still mined extensively. Nuclear phase out, hot topic in Germany. In 3 years, all the nukes will be gone. And I recommend strongly books by Mark Ellsberg. First one of his books was Blackout. And you can imagine, or maybe not imagine, what a blackout means if it lasts for 12 days, not just for a few hours or 1 day. And that has to do with cybersecurity and smart systems and so on. So, in a nutshell, the introduction, recent years, scientific and political interest has grown a lot on these topics, like prosumers as well, but maybe less fast. There's still many questions out there for us researchers and for interdisciplinary discussion as well. There are many gaps and pitfalls as well. Pitfalls for policymakers, but maybe also for those scientists amongst us that like to take shortcuts. Sometimes we need to look deeper to avoid some of these pitfalls, and I'll point out a few of them. The 3Ds have been mentioned a few times: decarbonization, decentralization, and digitalization. Sometimes people add a 4th D, that's the democratization. The fact that energy is an essential good has been used in the literature to argue we should discuss energy, justice, and poverty separately from justice and poverty in general, right? Because it's so important, because energy is an essential good. Now, essentially, I argue along 3 lines: the Energiewende, the sustainable energy transition in the German language, and the 3Ds have enormous impacts on the income and energy equality and justice situations. So that also asks for some dynamic considerations on the science side and policy side. And there's a tremendous need to change the energy mix and the infrastructure. I think we're all aware of that. The question is, how can we model this and understand it and proactively give the policymakers recommendations? There are enormous complexities in the social systems, the technical systems, the economy, how it will be organized with the 3 Ds. And so we should try to at least holistically study the co-evolution of these systems or spheres as much as we can. Partial analytics, partial analysis is more and more out of time, I think, and not sufficient and adequate anymore. So that's a big challenge, I think, in research overall. And finally, the energy economists are often very much concerned just about economic efficiency, but mostly this is still absent in the justice and poverty debate, which is largely dominated by sociologists, anthropologists, and political scientists, but not economists. There are many metrics. The choice and interpretation should be made with care, and sometimes I wish we did more life cycle type analysis and dynamic analysis rather than just computing static, easy indicators. One of them I'll show you later, where Slovenia is ranking 6 in the world by the World Energy Council. Simplify, but not simplify too much. That's what Einstein said, more or less, and Leonardo had a very similar saying. Energy efficiency rebound has been analyzed, and I did some research myself on, in the context of poverty, poor households have higher rebound. So is rebound a good thing or bad thing? Should we try to reduce rebound effects? Well, people like Ken Gillingham told us we should look at the social welfare implications, not just of energy efficiency, but also of rebound, right? So maybe poor households should be allowed to have a higher rebound than rich households. Think about it. Smart energy technologies can enable better monitoring and better transparency, also regarding increases and decreases in energy poverty and justice. So maybe that's good news. On the other hand, we have more and more complex systems to analyze poverty and justice will likely not become a lot simpler than it is today. Despite of globalization, many energy systems of the future are expected to be more decentralized. And we had these established hierarchical centralized systems for 100 years or so. So there is likely more heterogeneity, maybe also more mass customization and more autonomy in the future on the side of consumers and prosumers. And finally, there's a need for multi-level strategic and holistic analysis, enabling spatially narrow and system-wide resources and requirements to take properly into account. Finally, social norms will change, have always changed. Economic incentives need to be adjusted to the new developments in order to foster economic efficiency, but also try to avoid and reduce poverty, achieve, maintain justice, and that all in a world which will be more cellular, modular, interrelated, and multidirectional regarding the technical system. I'm sure Dehan Parawan will then talk about this. I just spoke to him. We have met 20 years ago. We were in a joint project when I was still living nearby Ljubljana, and we worked on cogeneration at that time in a freshly liberalized market, 1990s. When you Google prosumer households, you find an entry, and that's an entry to this ecological economics article we published earlier this year on prosumer households. We try to identify econometrically whether they are really different from consumer households, and we didn't find evidence or sufficient evidence. Do more research on that. I think this is one of the first pieces along that line. There are not so many out there. With Christiane Rosen, former PhD student of mine, we developed local reserve energy markets, and we had the idea how this has implications for prosumers, but also utilities and stakeholders, and we called it the energy eBay or something like that. Maybe you know the articles by Richard Green, who is at this conference that had the EAP Best Paper Award a few years ago, and the work by Wolf-Peter Schill. I haven't seen him yet, but they also worked on prosumage economics, so to speak. And we did a German project on the prosumer households. Most of the output from that project is in German, I'm afraid, including this book on the Bürgerstärken, the citizens' empowerment, quite an interdisciplinary authorship and project team we had. I think Ulrike Lehr is here from GWS. They were also involved in this project. And Institute for Ecological Research in Berlin, the Iaee. I'm an editor of Energy Policy, as some of you know. I noticed there are several special issues. One of them, at least, I handled until 2 weeks ago. It's the last bullet point here. Many of them focus on energy justice and energy poverty, so I think these topics are on the rise. Even Applied Energy had a special issue. That's a journal more focused towards engineering. And there are also articles reviewing the energy trilemma discussion or introducing terms like exnovation. I come to that a bit later. The Energy Research and Social Science Journal likewise had special issues and dedicated articles to these topics. And I think a few days ago, I noticed even Energy and Buildings had a special issue on energy poverty varieties. So I think that's enough evidence that these topics are on the rise. And finally, a hint on our book published in September this year, and a reference to the article on which my presentation is based on, Inequality and Energy. Now, the technical system, sometimes I attend many engineering conferences, and many of my colleagues in Aachen are engineers, very committed ones. And then we should not forget that this might be very fancy, sexy, fascinating, but on the other hand, this will not solve likely all our problems, let alone lead to equality or justice. And the United Nations, with these 17 sustainability goals, is always a good reference to go back and what are the main problems? Where is energy? Where could we contribute as energy economists to more sustainable development in the future? The number of energy prosumers is increasing. When we did this study for Germany, we found about 1.5 million households out of 42 million are prosumers, usually having photovoltaics. But there are also other institutionalized settings like virtual power plants, microgrids, energy clouds, energy communities, leading to new corporations. There are several presentations at this conference. And a central part of the sustainable energy transition has this potential to shift to emission-free electricity, to combine also blockchain technology, peer-to-peer networks, fancy stuff. And eventually this likely leads to decentralization, diversification, and democratization of the energy sector. From a technical viewpoint, Dehan, you might correct me, prosuming effects seem to be fairly straightforward. From the economics and social perspective, I think there's still much research to be done. And from Wolf-Peter Schill's article with his colleagues, I took these distributional effects because they had a list of pros and cons of prosumage. On the cons side, you see two, rebound and distribution. And here you see the arguments, interaction with grid charges. Energy-based grid charges increasingly burden non-prosumers, the prosumage mainly in the upper segments of the income distribution, and the exemptions for self-consumed electricity. Now, I think many of these arguments against prosumage can be relieved by proper policy designs. Now, electricity, space heating, and water heating are considered as essential goods, at least in developed countries, so that means low elasticity of demand, at least up to saturation, and it's certainly important to have energy for individual well-being and social participation. With large proportions of income that have to be used for energy, this is then referred to as energy poverty or fuel poverty. I'll have the definition later. And this goes back to the United Kingdom, 1970s. They had a strong focus all the way until today on fuel poverty. Boardman is an important reference in that context, and important influencing factors for energy or fuel poverty are low incomes, obviously relatively high energy demands, inefficient devices, relatively low energy efficiency, and high energy costs. You see some price developments of energy carriers for Germany, rising prices, and I think Germany is among worldwide having the highest residential electricity prices at about 30 cents per kilowatt hour. This is the timeline. I understand you get the slides, so I can skip this one, but it's interesting to go through the history of fuel poverty discussions and research. What is energy poverty? There is a general discussion on poverty and justice, and some colleagues took this further to the context of the sustainable energy transition. Energy poverty usually means no access to modern services of energy, whereas fuel poverty refers to inability to afford adequate warmth at home. So the fuel poverty term was introduced in the UK, 1970s. Energy poverty goes all the way through the literature and is often applied to developing countries. Often they're used synonymously, so I thought it's useful for you to see the distinction. Also, to distinct energy poverty from energy justice, justice has three dimensions: distribution, procedure, and recognition. That essentially means how are burdens and benefits being shared, distributed. Procedure means how do we involve the different people affected. And recognition means how do we pay respect. And when we talk about life cycle analysis, the respect for the fancy technologies we use in developed countries might have implications to people far away where we don't really care much about, right? Think about your mobile phones or laptops, in the future electric cars. That's a heavy, heavy backpack we have with these technologies, and sometimes it needs to be asked, is this just on a global perspective and not just on our national view? Spatial aspects are also interesting to look at, the geographical dimension of energy equity and inequality, and there is an issue of measurement. We want to measure energy poverty, so we need some suitable metric, right? Some matching metric with the poverty limit, which is normatively defined. The problem is assessment of the extent of energy poverty depends on both. And to illustrate this, from Heindel, which is, by the way, good reference from ZTW Mannheim, he did nice work with his colleagues on this, listing the different definitions that have been introduced on fuel poverty. That's the table. And standard definition is this 10% rule, that if you have to spend more than 10% of your income, probably real net income, on energy, then you're considered fuel poor. But others have introduced other definitions, and if you put this all into empirical research, you find for Germany here that there are quite differences in the outcome. How many people of the population are considered as fuel poor depends a lot on the definition you have. And then Heindel also points out that if something changes, policymakers should be very careful. If the poverty number goes up and down, this could be illusionary because it's a distribution of expenditures on energy, and it's also population. So if individual positions in this distribution shift, it may or may not have to do with fuel poverty. So they ask for being cautious on these measures, and policymakers need to decide which measure they consider the appropriate one. Right? One slide on Knut Wicksell and Eric Lindahl, famous economists from way back when, on public goods and what they did on justice. They thought there should be a distinction between social justice and economic justice. You see what the differences are on the list. Economic justice requires anonymous agreement between political representatives, leading to what has become known to all of us as economic efficiency, right? They ask for respect for individual interests and elimination of power abuse. They warn of power asymmetries as a main danger for economic justice or injustice. And not so much they are concerned of principalization, problems of free riding and size of the government. And policy space, according to them, is inherently multidimensional because the supply of public services has to be simultaneously determined with the distribution of the costs. So I think that's some of the thoughts and arguments economists can carry into the justice discussion, dominated by other disciplines so far. But what does it mean for energy justice? Energy justice. How much public service will we see in the future? When we all talk about this distributed, digitalized, peer-to-peer networks in liberalized market economies, how much will be still public service? Think about it, and then we can discuss again what Wicksell and Lindahl had as arguments, right? If you look at the World Energy Council, they asked for 1.5 tons of oil equivalent per capita and year for everyone as a minimum for adequate economic and social development. If you look at the small print on this graph, on the left bottom corner, you see the world, maybe you don't see it, 1.79. So the world on average, 1.79, but you also see much smaller numbers, right? So this is a strong distributional issue. How can we make sure that 8 billion people on this planet will have this minimum level of energy available for a more or less livable development, right? You see the bar chart, which shows you the OECD has more or less stabilized in terms of primary energy consumption per capita by region, and the developing countries are on the rise. Now think about it, whether this is good news or bad news for energy poverty and energy justice. Not so easy to read that from this simple bar chart, right? Now the energy trilemma analysis of the WEC, you see it here, the 3 dimensions, as I said before. Here they use energy security, energy equity, and environmental sustainability. You see some explanations in blue. And then they do this ranking, I think, for the whole world, right? I don't have the time to go into all these details. You see Slovenia doing very well, higher ranked than Germany. China is catching up quite a bit, but still ranking much lower. And then you see that this is a very nice, practical, and maybe transparent way to score and benchmark the countries of this planet. Now, I didn't look that detailed into this report. It's like a doorstopper from the format to find out what are the shortcomings of their methodology. And if policymakers like this kind of representation, then they should be cautious whether this really tells us all we want to know about these trends. Yeah, and GDP levels, I'm not going through this. Different countries have different GDP levels, and that has implications on this energy trilemma situation. Others have thought we can put this into different terms. You see here economics, brackets finance in one corner, politics and energy security in the other one, and environment, climate change mitigation in the third corner, and justice somewhere in the middle, dominated by law and policy. Different ways to represent this. Others have said, yeah, countries like Germany, they put way too much focus on security of supply and economic viability and not enough focus on environmental compatibility, and usually they did not look at social acceptance at all. They call this energy crossroads and use Germany as an example, and you all know the policy there, phasing out nuclear before coal, and sometimes you wonder why do they do it the way they did, right? Of course, that also had to do with social acceptance and preferences of citizens. Now, to look at energy inequality, we need to look at the dimensions. Temporally, we can look at the dynamics over time. Sectorially, we can do intercontinental analysis, interregional analysis. We can do quantitative or structural research. We can look at it from a relative or absolute point of view, and it's dependent, among others, on income, prosperity, but also production and consumption activities and lifestyle. Think about what it means to be cold in a Norwegian household, right? A, they have harsh climate. B, they have a lot of energy. B, it's quite a wealthy country. So how many people are fuel poor in a country like Norway, right? So it has also to do with the main energy resources available or traditionally used. It has to do with the physical infrastructure. Think about windmills versus power lines as a discussion, and more people affected by decentralization as a question posed here, and the climate-related issues. Building stocks are often built according to the climate, and then fewer people are at danger to freeze to death, right? The UK might be a very special case in this sense. Now, we did some regional econometric analysis, fancy approach. If you like to look at it, it was published in Utilities Policy earlier this year, where we tried to map the energy transition in Germany on a very high resolution level. We went into the commuter classes, the labor market districts, and the labor market regions, so 3 different regional breakdowns of such data, and then we looked at the value added on the Kreis area and very detailed on these labor districts. And we found then for 3 different industries, chemicals, metallic industry, and mechanical industry, what the energy transition in this state of Germany, North Rhine-Westphalia, really means to the different local regions, right? So an interesting way to go about this, and I think we pushed the way this can be analyzed a bit further. This is based on input-output analysis, but this detailed mapping is relatively novel. Yeah. So, life cycle analysis, I don't have the time to go into this. It's a lot of work to do proper life cycle analysis. But some of my colleagues, and Stefan Vögele is here from Jülich Research Center, also did some social life cycle analysis to look at this not just from the fuel cycle or the product life cycle, but also from a social life cycle analysis. Where are people affected in what way along the whole cycle, right? And because I'm running out of time, ex-novation, just as a term that you have heard it, this means we need to replace the old, the unsustainable infrastructure, technologies, products, practices. That's kind of the downside of the fancy new technologies that need to be invested in. And this might also create some resistance from the different stakeholders losing something. And so ex-novation, a term that was introduced in the 1990s, I think, and recently popularized by David, is an issue that has also not been researched a lot. Now, Ginny and Lawrence, I think I just briefly mention how this goes. You can do country comparisons with this. You can look at electricity or energy, and you can compare energy with income inequality. An article by Jacobson in Energy Policy 2005 is quite interesting in terms of what we should take care of as economists. Marginal utility over the whole income spectrum that is shown in the right graph on top as a check whether the equity indicator is really viable. Trends, they also looked at, I'll skip that, and very important, taxes and levies. They can be progressive, neutral, or regressive, right? And Germany is a famous example for their subsidy schemes, 20 billion every year imposed on mainly residential households. And some studies have shown this is really regressive, i.e. the poor people suffer more from the energy transition than the rich people do. E-cars, maybe a rich people toy still. This was work done by Heindl again, where they looked at the increase in the electricity price, that it really hits the poorer people harder than the richer people. That's no surprise. The levy has risen to more than 6 cents per kilowatt hour, will go down in the next year, so that's less of a burden on households. That will have a distributional impact. And if you look at the development over the last 10, 15 years, 110% increase, that's the figure on the very right. German households now pay more. This is broken down by taxes, duties, transfers versus grid charges versus the power price. So that's quite an increase, and especially poor households suffer and struggle with this. To conclude, the scientific and political interest in the topics prosumage, energy poverty and justice has increased in recent years. Prosumers are building blocks for the decentralization, social participation, social acceptance, but not every household will be able to become a prosumer. Think about that. The origin of the energy justice debates comes from the environmental justice literature. There's also something called climate justice, to keep it separate. And the relatively long history of the fuel poverty debate in the United Kingdom. The analysis of energy poverty requires a measure and a metric, and the existing metrics often produce different results and should be interpreted with care. Social and economic and ecological injustice leads to numerous dimensions to be studied. The energy trilemma I pointed out, it's not uniquely defined. It's usually static, it's usually very limited. And justice aspects are actually to be found in all 3 dimensions of that corner of the trilemma, right? Energy poverty and justice is also relevant for guiding any sustainable energy transition proactively, not least for bearing the cost burden of the energy infrastructure, old and new, and replaced, and maintaining social cohesion, social acceptance also of this transition process, which could eventually trigger large costs. If the Energiewende in Germany breaks down, that also would imply some costs. So policymakers are well advised to take it into account when they plan the further energy transition processes. Life cycle analysis, don't go into that. The energy transition implies a shift towards new business models, lifestyles, new policies, and energy poverty and justice is just likely has to be redefined and reassessed. We need new metrics, we need economic analysis and good guidance for policymakers. Energy economics can contribute to the debate. An inefficient system is not a just system, we can assume, and the economic implications of the sustainable energy transition are enormous, and as are the potential distributional and poverty consequences. Thanks for your attention. Hope I didn't take too much time.
So I will just tell a very short story of mine and also of Iaee. Actually, it started when me and Reinhard and all the other colleagues successfully concluded that project on cogeneration, and I did or finished my PhD and then moved to the business. And actually, at that time, 3 or 4 people of us were motivated to start the energy business here in Slovenia with certain blue chip companies, and we started developing energy trading and sales since that was the advent of opening of electricity markets. I'm telling this story because we are in a very similar situation that also other utilities and other energy companies are now, and in order to show how we are thinking and how also the others are thinking and why we are now in such a hurry of changing things. So during these years, we grow in revenue, we grow in customer base, we grow geographically and spend all over Europe or over more than 20 markets. And actually what we did was that we focused on 2 major businesses, and our goal was how to bring benefit to customer in terms of what market can bring. Okay, and this is here an example where the example of opening of gas market in Slovenia. Actually, it was not when the market was opened, but by regulation, because that was in 2006 or 7. But since then, there were about 17 suppliers in Slovenia, but actually there was unofficially nobody was competing with nobody. And actually the situation deteriorated. As you see above, especially in 2012, it was pretty, the average price paid by Slovenian customer were higher than the average in EU. So the gap increased quite a lot, as in household segments, as also in business segment. And this was where actually the customers forced us to enter this market. We brought competition and we brought value to customers, because if we calculate only what is the difference in million euros that customers spend compared to EU average, actually in each segment we are talking about millions. So this was our main goal and purpose, how utilizing markets bring benefit to customers. That's why we developed those 2 core businesses, energy trading and energy supply. But you all know that things are changing, and now we are establishing a 3rd pillar and moving much more towards energy services and developing different energy services, how to help pave the way for the energy transition and decarbonization of everything. All this is happening because the technology is improving a lot and because there are new elements in the grid. So we all know that home of future will be very complex. It will be combined of solar power plant, battery, e-mobility, connectivity, electrical heating, and so on. So we have already, I heard for the first time today Prosumage, so that it's already an evolution of Prosumer, so that we add also battery storage. So the complexity behind the customer is increasing enormously. And this is actually why we need different services. Now, I believe that most of you are economists here. I'm power engineer. So I will show you how we, as power engineer, were taught who the consumer is. So on the left side, you see the typical, how we look at the grid and how we look at the life, okay? This is the typical scheme of a grid. The consumer is one sign there, and actually how we called consumers are loads, okay? This is not a joke, okay, so that the consumer is load. But the whole power system was constructed in last 100 years with the goal in mind that whatever the consumer needs, we will provide, okay? And the need of consumers were pretty simple and pretty straightforward because they only consumed, and they consumed more or less very similarly. So you could have different patterns, but it was very predictable. So also power engineers are not looking, from above to customers to call them loads, but this is how we perceive consumers. Now, with all this happening behind the meter, the customers are not more loads for the grid. Actually, they are becoming active, and even more, we cannot look at consumers as spoiled children who can do whatever they want, and we will provide them whatever they want, because we engineers will easily, we cannot make it, okay? If we get rid of fossil fuels and so on, the whole problem becomes so complicated that without help for customers, we can just not solve this issue. So for that reason, the active customer term is introduced, and we want to stimulate customers for right behavior, also because he has a lot of tools now behind the meter, which, if orchestrated correctly, they can provide services to the grid and provide solution for solving this issue of decarbonizing power sector. Also, politicians recognized this situation, obviously, and we are already evolving the market models. So this is the picture of retail market design, one of possible solutions according to the European Clean Energy Package, where new entities rise here, aggregator and so on, and actually on the left side, the picture becomes more complicated because we have now active customers there with a lot of tools which interact not only with supplier but also with other parts of the market. And with all this environment which is changing, actually we, as a, let's say, conventional, still newcomer, but supplier of energy and trader of energy, we are now, of course, seeing that now the space is opening, and that new business models and new solutions, especially for customers, are needed. And that's why we are also directing our research in that direction. This is one way of picturing the innovation landscape. It's according to Pisano, a paper from HBR, where actually we can distinguish different innovations and innovation strategies depending on one axis we have whether we evolve current business models or we create new business models, and on the other dimension we have technology and technology competencies. Either we develop our current or we need to utilize new one. This landscape is very familiar to me because actually we also think in those two directions. So we are thinking on how to embrace new technology, because the new technology is evolving very fast, and also how to develop new business models that will stick to new customers' needs. Now, we don't have a crystal ball, okay? So we don't have very short or simple solutions to these issues. And actually, as our situation and how we look, I quite believe that a lot of other companies also look. And that's why there is now a huge hectic that actually you need to innovate and you need to do something. And everybody are doing a lot of stuff. Although not many projects and not many of these services are self-sustained and are economically feasible yet. So that's why currently I feel very lucky, because where I am, it's total adrenaline, and actually it's a lot of fun working in this sector. A lot of people are putting a lot of effort, and let's see what will come out. So for this reason, I will show you just how we at Iaee are thinking and what are we doing. So we believe in we were talking about 3D, 4D, 5D, whatever. So the trends that I would put front, which we believe that will definitely shape our future and which we need to embrace, are the following. First, digitalization, especially because also in energy, this space can improve a lot. Second thing is electrification. So if we want to decarbonize, we need to electrify a lot of stuff. And the third thing is, of course, the ultimate goal is decarbonization. So in this direction also we are, because we believe that these are the trends that will shape our future, we are turning our projects and our development of solutions for customers. So digitalization, it means that we need to start with our internal processes, how to optimize them and automate them. Then, of course, we need to embrace new technologies and new knowledge, referring to big data, machine learning, artificial intelligence, and so on. Actually, already the cogeneration project had artificial neural networks in and genetic algorithms and so on, so already 20 years ago. But now, of course, the machines are so powerful that all this can be commercially viable. We need to establish new ways of customer communication, and on top of this, we develop new digital products and services and combine them with new business models. Just to give you a glimpse, so the digitalization, we establish it all over our value chain, but just a few examples. For example, in trading, what we do, we have here one hydropower plant in Albania. There is no way to get data, how much water is that baseline. So what we did, we put few guys together, and then they utilize the satellite images and make image recognition, and out of the surface of the river basin, they calculate what is the volume in. When they calculate what is the volume in, they can predict better what the prices next week will be, and then how we actually optimize our portfolios. Second thing is that on markets, especially when talking about commodity prices, there is a lot of market sentiment. So where to embrace market sentiment? One thing is utilize social networks. So what people are talking about and how they are thinking. And again, we are utilizing a lot of data, how to produce out of this mess of data an indicator of market sentiment, what market believes, and utilize this as a factor in our fundamental models of how to construct and how to value what the prices are and where they will move. For this reason, we increased a lot the number of employees. Now this is the increase of all employees in the group from 2016 until the end of this year. We'll come to approximately 500 people, and majority of these increases, or at least a lot of these increases, are data scientists and analytical people, developers, and so on. So basically, we are heavily investing in human capital because we firmly know that we will need this in order to develop new solutions. The second trend, electrification of everything, it combines 4 pillars. e-mobility, of course, electrification of transportation, heat pumps as a way of electrification of heating, demand response for industry, and energy storage. So what we do, just few examples. So here is one pilot project where we constructed with two different partners who are not part of Genai. We constructed an autonomous EV charging station using distributed ledger technology. So it's a microgrid system, it's off-grid system, it's not connected to the grid. And I have a short video, so just to show you how it works. Actually, the system combines of power storage, then a solar power plant, an electric car, this yellow one, which is hacked, so it's V2G, so it can be also reverse, so it can charge, send energy to this microgrid. And then, as you will see, a second electric car will come, which wants to get electricity. And actually, with distributed ledger technology, we constructed application so that actually machines talk between them without any human intervention. And then actually they trade and exchange energy and also settle the account. And the DLT technology behind it's IOTA, okay, it's not blockchain. Actually, in most of the business models and solutions that we try to evolve, we try to do that as much as possible is automized, obviously, because the comfort of consumers usually should not be hurt or deteriorate. The next thing is how to utilize heat pumps and operation of heat pumps, because you cannot imagine how stupid the heat pumps operate, actually, as they are alone in the total universe. And actually, with shifting the operation of heat pump and just looking what the temperature in the room is, we have a lot of potential of switching the demand. And again, these are pilots where we try to operate with heat pumps, not deteriorating the temperature in the room, and actually then utilize that flexibility in electricity markets. Then the next thing is the demand response in industry. This is something that we already commercially do. So actually we have a virtual power plant connecting consumers and then selling different flexibility products on the market, and in such a way a consumer can get, again, an additional revenue stream. And the last thing, a case of philanthropy house here in Ljubljana, where we constructed a microgrid with battery storage management. It can work off-grid, together with the grid. There is a solar PV on the roof. It has also a charging station, and actually then we developed the optimization software and management software so that actually the costs are minimized of the whole system. The third trend, decarbonization, it's again pretty obvious. So we are targeting here self-consumption with solar energy because wind in Slovenia, it has not a good karma, I believe, because we have, I believe, two not 2 power plants, okay? We have two windmills, yeah, altogether. So we see that the solar energy has much larger potential in residential solar, in community solar, so in multi-apartment houses, and in industry. And all those roofs, without deteriorating the environment, we can put solar on it. And that's why, again, we developed and we are actually commercially selling different solutions for individual self-consumption. We have something like 1,000 installations now in Slovenia. Then for apartment buildings, this is a case in Jesenice, where there are, I believe, 20 or 30 apartments all together, connected then to one solar power plant, and each one decided how many panels work for them. And we are providing also solutions for industry. Again, in industry also, these cases are economically feasible, and actually the industry can already reduce their carbon footprint by installing self-consumption power plants on their roof. So these are, on short, our directions where we go. I believe that a lot of other companies, of course, do similar things, and the whole. I don't believe that there will only one business model will emerge, not at all. So it will be an evolution of all these business models, which will combine and integrate at the end. Thank you.